Good morning, everyone. So we have been studying about binary frequency shift key. So last class we saw about Bfsk signal, constellation diagram. We saw about the signal waveforms. We saw about generation and detection of Bfsk signals. In today's class, we will see the probability of error of Bfsk signal. So as we derived it for Bpsk and Qpsk, we have a small derivation to find what is the probability of error of Bfsk signal. So we'll look into that. Meanwhile, you can mark your attendance. Please write your register number and name on the live chat so that I can mark the attendance. Okay, so please keep typing in your attendance, register number and name. So let's go into the class. So we will see this topic, probability of error of Bfsk signal. And as an introduction, hope you remember the constellation diagram which we drew last class. So there are two axes, phi1 of t and phi2 of t. And remember the points. It was square root of EB 0 and so this will be square root of EB comma 0 and this point is 0 comma square root of EB. And how do you find the decision boundary? You draw the line joining both of them. Okay, mark this point. You draw the line joining both of them and the perpendicular to that. So we find that that will pass through the origin. That should pass through the origin. That will pass through the origin, and actually this line is actually x1 equal to x2 because you can think like that, no? Because we have something like 2 comma 0 and 0 comma 2 and you are drawing the two both of them together, and then perpendicular to that will be the line which will be equal to x equal to y equal to x, like that. So this will be if this is the point x1 and this is the point x1 and this is the point x2, then this line will be x1 equal to x2, and we have two regions as previously we told, no, we have two regions z1 and z2. So what will be the region z1? Region z1 will be the place where x1 is greater than x2. Remember, x1 and x2 we talk in terms of the received signal. So region z1 will be the region where x1 will be greater than x2, and region z2 will be the region where x2 is greater than x1 or x1 is less than x2. So that is how we identify the two regions. Okay. Moving into the calculation of the probability of error, let us suppose that we are transmitting as 0. Let us suppose that 0 is to be transmitted. So we are transmitting, corresponding to that, we are transmitting the signal S2 of t. And in this there is an error in the transmission. So the received vector, what will be our received vector? We can write received vector, which will be usually we write x, we will write received signal as x of t is equal to S2 of t plus W of t, and received vector, no, that will be our x, lies in region, it has to lie in region Z2, but because of the error it lies in Z1. Now that is why when it lies in Z1, remember x1 is greater than x2. See the figure, S2 was transmitted, so 0 comma square root of EB was transmitted, and that is a symbol to be transmitted, or the coefficients of the basis functions to be transmitted, and we transmitted S2, so we have to, our observation vector should be in Z2, but there's an error, so it lies in Z1. Now we have to find the probability of error. Now, so what we do is, let us assign y is equal to x1 minus x2. So we take y as a random variable. So y is a sample of random variable. Okay, we definitely see, we know x1 is a sample of a random variable capital X1, and x2 is a sample of a random variable capital X2, and we take the difference of two Gaussian functions. Say random variable, they are all Gaussian functions, no? And when we take the difference of that, we will get another Gaussian function. So it's a sample of a random variable y, and which is a Gaussian random variable. Okay, and let us see what is the mean of. So x1 and x2 are, they are also sample of random variables. Whose mean are, see what is the mean of x1 and x2? So it will depend. So it will be mean as square root of EB and 0 if symbol 1 was transmitted. Because we know when 1 is transmitted, it is square root of EB comma 0, that point. So x1, mean value of x1 will be square root of EB, and mean value of x2 will be 0. And it will be 0 and square root of EB, right, respectively. Okay, here also you can write respectively. When 0, symbol 0 is transmitted. Because when 0 is transmitted, remember the coefficient values are 0 comma square root of EB. So the mean value will be 0 and mean value of x will be 0, mean value of x2 will be square root of EB. So that is why we write these two conditions. Okay. So we have to find the conditional mean because we have a condition here. So we have to find the conditional mean. Conditional mean y given symbol 1 was transmitted. What is that? I am writing it as expectation. Expectation of y given 1 was transmitted. This is equal to expectation, because y is equal to x1 minus x2. We have to write x1 given 1 minus expectation of x2 given 1. So what is expectation of x1 given 1? We already wrote, which is equal to square root of EB. And what is expectation means is the average value of x2 when 1 was transmitted, it is 0. So this is equal to square root of EB. Okay. And one more condition, what is the expectation or the conditional average of y given symbol 0 was transmitted? What is that? That is expectation of y given 0 was transmitted is equal to expectation of x1 given 0 was transmitted minus expectation of x2 given 0 was transmitted. So if 0 is transmitted, x1 expectation is 0 and x2's expectation is square root of EB. So this will give you the value, this will give you the value minus square root of EB. Okay. And let us see, before we find the mean values. Now we have to find what is the variance. Okay, so what is so what we find is the variance of random variable y is independent of which binary variable is transmitted. Okay, so we find that this random variable x1 and x2, they both have a variance. They are independent. They are statistically independent with variance n0 by 2. So we are going to use this. They are statistically independent with variance n0 by 2. So there's actually a property like you can note. Maybe this is useful for your other general knowledge also. So variance of a times x plus b times y is equal to a square into variance of x plus b square into variance of y. Because of remember, variance equation always have x minus mu the whole square. So because of that, it is 1 by n into x minus mu the whole square. So it will be, when you take it outside now, so it will be a square will be term. So remember this thing, and we are going to use it for our property. In our case, variance of y will be equal to variance of x1, because they are independent. No, we can just add of x2, and this is equal to n0 by 2 plus n0 by 2. So n0 by 2 plus n0 by 2, and that is equal to n0. So variance is equal to n0. Okay. Now we have to find the we know the we have to find the probability of error, and when you find the probability of error, we use the condition probability density function. Okay, so let us see the condition. We have considered the condition was when symbol 0 was transmitted, there is an error, and the symbol received is 1. Okay, so that is the condition that we are looking into. Okay, so we will see the probability of error. Okay, so that I am writing it by the notation P10. So P10 represent the condition when I received 1 when a 0 was transmitted. Okay, so this is equal to, what is that equal to? It is equal to probability of y greater than 0 given symbol 0 was transmitted. So probability that y greater than 0 means probability of x1 greater than 0 given 0 was transmitted. Okay, sorry, x1 greater than x2. That is our condition. Okay, so we will write this as, anyway, this is actually equal to our conditional probability density function. So 0 to infinity f of y given y dy. So f conditional probability function of y given 0 dy. And what is that? We know this is a Gaussian random variable, so I can write it as 1 by integral from 0 to infinity 1 by square root of 2 pi into sigma. Sigma here is n0 into exponential of minus 1 by 2 into x minus See the probability of y given 0. What is the mean in that case? The mean in that case is minus square root of EB. Remember, we derived mean for both the conditions. So mean of y given 0 is actually equal to minus square root of EB. So it is minus square root of EB the whole square by 2 sigma square. So that is equal to answer. And then I have dy, right? Sorry, here it is not x, here it is y, because for time being we are considering y. So that will become, when you simplify it now, what will it become? It will become equal to y plus square root of eb the whole square. So I am going to do, we will put the substitution, put u is equal to y plus square root of eb by, okay, let us put 2n0, square root of 2n0, because we had 2n0 in the denominator. We'll write it as square root of 2n0, so that you can substitute u square, no? So what is du? Du is equal to dy by square root of 2n0. So dy is equal to square root of 2n0 into du. Now my substitution of the limit, when y is equal to 0, u is equal to square, okay, u is equal to square root of eb by 2n0. And when y is equal to infinity, u is equal to infinity. So I am going to substitute all these values. So what is my equation? It is, my equation is P10. This is equal to 1 by square root of 2 pi n0 into integral. Well, it was 0 to infinity. Now we will have square root of e. Okay, let me see, square root of, it is eb. Remember eb. So it is, if I'm told e0, excuse me, it is eb. So it will be square root of eb by 2n0 to infinity exponential of minus u square into, instead of y I am going to substitute square root of 2n0 into du. So what will I get? This is equal to, simplifying, this part and this part will get cancelled. 2 and n0 will get cancelled, square root. So what remains will be 1 by square root of pi into exponential of eb by 2n0. It is square root of eb by 2n0. Yes, to infinity exponential of minus u square into du. Okay, and this I can write in terms of ERFC function. ERFC function is 2 by square root of pi into exponential of, and see here the limits also, it is from, remember we had a graph, like we had a Gaussian shaped pulse, and ERFC is from this to this limit and from this to this limit. So in the positive, so here that is positive itself, so there is no need to write 1 minus and all. So I can write P10 is equal to 1 by 2 times ERFC of square root of EB by 2n0. Okay. So what so this is for this probability of error when 1 is received, when 0 is transmitted. Similarly, I can write P01. This is also equal to the same. And what is the total probability? Probability is equal to actually P10 into P of 0 plus P01 into P of 1. Since both symbols have equal probability, equal to 1 by 2. Equal probability, I can say P of 0 equal to P of 1 equal to 1 by 2. So how can I write my total probability of error? This is equal to 1 by 2 into, 1 by 2 into 2 times 1 by 2 ERFC of square root of EB by 2 and so. So again, that is equal to 1 by 2 ERFC of, this is my final answer. This and this is going to get cancelled. EB. So probability of error is 1 by 2 into ERFC of square root of EB by 2 and so. 2 and so. Okay. Now, how do you, what happens when you compare with Bfsk signal? So, probability of error of Bfsk signal is 1 by 2 times ERFC of square root of EB by N so. And sorry, Bpsk. Probability of error of Bfsk is 1 by 2 times ERFC of square root of EB by 2 and 0. Okay. Now N0, it is a variance. It is not a problem. It is this is the same. Sorry, it is both the same. But what about EB? EB is the energy per bit. So first case is the energy per bit of the in the case of Bpsk signal, and second is when it is Bfsk signal. So which term is more, EB by N0 or EB by 2 N0? So EB by N0 is larger, greater than EB by 2 N0. So remember ERFC function the പ്രത്യേകത എന്താണ്, when U increases, ERFC of U will decrease. Okay, so we find that Bpsk inside that bracket, no, square root of EB by N0 is greater than square root of EB by 2 N0. So probability of error of Bpsk will be always a smaller value than probability of error of Bfsk signal. And why it is, see, you can compare in terms of the constellation diagram also. We draw the constellation diagram for Bfsk and Bpsk. This is for Bfsk and this is for Bpsk. So in Bfsk, what we can find is the 2 points, In Bfsk, we know that the 2 points are at 0, comma square root of EB, square root of EB, comma 0, and here it is at 0, comma square root of EB. But in Bpsk, we know that the points are at square root of EB, comma 0 and minus square root of EB, comma 0. These 2 points. So what is the difference between the 2 points? What is the difference? What is the distance between the 2 points? These 2 points, the distance is square root of 2 EB that you found last class. But what you find the distance between these 2 points? The distance between these 2 points are 2 times square root of EB. So we find the 2 points are far apart in the case of Bpsk, but they are closer in the case of Bfsk. There is one more correction which I want to tell is, okay, I will explain this after explaining to you one more thing. See the probability of error of Bfsk and Bpsk. Bpsk is 1 by 2 times ER of C of square root of EB by 2n0. And probability of error of Bfsk is 1 by 2 times ER of C of square root of EB by 2n0. So if the probability of error has to be same, no, then the energy per bit in Bfsk should be double that of Bpsk. Okay. So if you want if probability of error of Bpsk and probability of error of Bfsk has to be equal, then energy per bit of Bfsk should be twice that of energy per bit of Bfsk, Bpsk. Because see, if you want these to be equal, then in this EB should be 2 times that of this. So let us take this to be EB1 and this to be EB2. Then if they have to be equal, then EB2 should be 2 times that of EB1. Then only if you substitute, you will get both the same equation. So that is one. EB2 is that of Bfsk. So the energy per bit of Bfsk should be twice that of energy per bit of the Bpsk. This is another important difference. And here if we come now, so distance between them, in one case it is square root of 2 EB, other is 2 into square root of EB. So definitely this is more far apart. Okay, so the points are more far apart in case of Bpsk. So which has more effect of noise? The same noise affects both Bpsk and Bfsk. Then we find that since these ഇത് രണ്ടും അടുത്തിരിക്കുന്നത് കൊണ്ട് നോയ്സ് കൂടെ വരുമ്പോഴത്തേക്ക് there is more probability of error. But ഇവിടെ എന്താണ്, ഇവിടെ കുറെ നോയ്സ് വന്നാലേ ഒരു റീജിയനിൽ നിന്ന് അടുത്ത റീജിയനിലോട്ട് കടക്കത്തുള്ളൂ. Okay, if the point that is supposed to be lying in region Z2, if it lies in Z1, then we say there is an error. So the probability of error will be more in the case of Bfsk than in the case of Bpsk. So more the distance, more is the distance between them, the probability of error will be less. So Bpsk has lesser probability of error when compared to Bfsk. So these are the comparisons between Bpsk and Bfsk. So in this class we have seen what is the probability of error of Bfsk and we have compared Bfsk and Bpsk.